I think before we start, if there are any questions to Rukma ma'am about assignment or first chapter.
Ma'am, one doubt I have is
One
this
minute, I think my audio is so low I can't hear you. Yeah.
like normally like in this chapter what we have learned is about the spec, the rating and all for a system, so like based on its performance and all. But in the present day, like I never heard of people talking about that. So like is now,
Talking about spec benchmarks.
yes ma'am, like this is the first time I heard in this course about that word.
Well, you probably are only buying laptops, so people may not be talking. I have to call up NRSA folks and ask them whether they're still doing benchmarks.
Okay ma'am.
Because when we used to buy in NRSA, we did run huge amount of spec benchmarks before we fixed on the servers.
Okay ma'am.
I mean, of course, that is so long ago. But I think um, we can ask Chakravarti sir because he handled CMSD,
Yes.
which has so many high computing platforms. What is it they do on the server purchases there? We can find out because they bought power servers there. Lot of or IBM, yeah, IBM actually delivered them. So did they do any spec benchmarks? I remember he told once, uh, the teraflops per second that power server is capable of, and also I guess they'd still do that at the high end.
Maybe in the normal basic usage, people actually don't you think about that, but
Yeah, I mean, like, see, for the PC, laptop, all these things, the amount of computing power we have is so much higher than what any of us use. In fact, we don't use the power of one processor or one core in our system, and most of our systems have four cores. So,
yes.
Ma'am,
yep.
yes, now I have a doubt. Is there a difference in the way we perceive benchmarks for servers and benchmarks for commercial desktops or laptops? Like for servers, we know that we'll be targeting other users because they need to be continuously on. So we'll be looking at pointers like mean time to failure or how fast the access to disk or something. So what are the actual differences between like a server's benchmarks and a consumer grade uh, benchmark? Consumer benchmark.
Okay. Um, Rukma, do you want to answer?
Knowing the desktop systems, it's more about the execution time, whereas one parameter that mostly people see, and when it comes to server, it is the number of transactions per second. Yes, that is true that we don't see the same parameters for both desktop and server,
Okay.
especially when it comes to servers. The throughput is considered in terms of the number of transactions that are done per second, sort of.
Okay,
Yeah, in the desktop, I think it's more I mean, it's not so important, though it's important, but in the server is so much more important. When you come to laptop, energy conservation becomes very important, which is not so much true in desktops, nor a lot in servers either. If you, all of you must be having a dual. I hope you're having a dual, boot up with Windows and Linux. But I know a lot of you use only virtualization for Linux with Windows as your main platform, which is very bothersome to me. Anyway, if you really have a dual boot, you would have observed that Linux is not at all good at battery consumption capabilities, right? I mean, it uses a lot of power compared to Windows.
Yes, ma'am, I did
Any
notice
idea
that.
why? Why do you think Linux is so poor in performance, in power consumption?
Because it's made for performance and all.
I think it's because the like Linux doesn't treat its user as an idiot, so it assumes that the user knows what is going to consume. So, like based on what processes the user runs, it will consume power as such. Whereas Windows will just baby everyone. So, in the background, if you're not using some user, it will. If it in the background, if you're not using some process, it'll just suspend it or terminate it.
Yeah, I mean, like partially true, but you have to remember that Linux is the operating system for servers, and Windows is the primary operating system for laptops, of course, partially because Windows is forcing us to use Windows. In fact,
Yes.
I think nowadays it's very difficult to make a laptop a dual boot because I made it so difficult to install Linux on a
Yeah,
already preloaded Windows, right?
correct. I tried
So,
with my system, I couldn't do that.
okay, now I'm trying to
And
buy
I
a
made it.
laptop. I'm trying to figure out how I'm going to handle that Windows stupid 10. So,
And the recent
I
ones are not allowing for the dual boards.
no, we have to struggle a lot because what they have done is they have modified the BIOS itself. So you have to really meddle with the BIOS to make a dual boot happen nowadays. So
Okay.
what they have done is they have in the BIOS they have certain keys installed. Only if the operating system matches that key will you be able to install that OS on that system. So some such thing they have done is what I heard. Anyway, I'm hoping that my expert brother-in-law will help me install Linux. Otherwise, anyway, I'll remove the Windows and install only Linux.
And there are
There
So,
was
many
a
driver issues also, ma'am. Like, uh,
driver issues will be there for any of the latest
latest.
laptops.
some most of the I had this problem since the time I bought my laptop. Like my laptop, when I try to install Ubuntu, I won't get a Wi-Fi driver.
Now you try. I mean, let's
Now
see
I'm
if
getting, ma'am. Like now after so many
not
reinstalling.
after so many years. I think after about a year after you bought the laptop, it should have been available.
You'll
You may
get that.
not have
Yeah.
tried it.
Like
See, again, think about it. What is the reason why we can't get that? Because, the hardware manufacturers build the device drivers for those hardware and give it to Microsoft. On either that or they give all the hardware information to Microsoft to build the device drivers in Windows. They do not make those hardware device specs available to the world.
yes, ma'am.
So how will Linux people write device drivers? I mean, I don't know how much of device drivers you people read, but you have to know what are all the registers which are there inside the controller and what bit of what register do you have to set or clear or something to, make it do a particular operation. So all that information is not available for the Linux people to write the device driver. So what do? They actually do reverse engineering from Windows device drivers somehow, and then write the device drivers for Linux. So it takes time for them to reverse engineer all that.
Ma'am?
These are all extremely, what do you call, disgusting habits of Microsoft. So, and the idiots are using Linux in Azure. So,
So
yes,
we have
Krishna.
Yeah, yes, ma'am. But wouldn't a drive or a device manufacturer send the hardware info out to companies like Canonical or Red Hat, because they do run even enterprise grade Linux? So wouldn't
Yeah, see,
wouldn't it?
some of them do, not all of them do.
Okay, because
It took a lot
because
of
if
effort for Linux people to come to the stage where now some hardware engineers, I mean, some hardware manufacturers are providing device drivers built in for Linux or give information to Linux developers. But still, there are, they have these contracts between Microsoft. For example, HP laptops have the contract that they come loaded, preloaded with Windows, things like that.
yes, ma'am.
They're all commercial. It's nothing to do with technical reasons.
Yes, ma'am.
I think
So
Rukma, you were
don't
saying something. Gayatri, you wanted to say something because I saw you unmuting your. Yeah, Gayatri. Okay.
no, Anurag's question was answered. I lost in between. Anurag asked a question saying during some part of the execution time is enhanced. Does that enhancement happen through overclocking? Uh, the answer is enhancement doesn't happen alone through overclocking. The enhancement can happen at many points or at many interval. It's like this: you have an execution unit, you can improve your execution time by using techniques like pipelining or some more that we'll be discussing. Or you have an instruction fetch unit where you can improve the fetching time by using some other technique. So overclocking is not the only mode of enhancement. You can do enhancement at various points by using various techniques. Hope Anurag, are you there?
Yes, ma'am.
Yeah.
What we are going to tackle is a series of questions that a computer architect, asks themselves when they are trying to design a new processor. Actually, how many of you, can somebody tell me what is the, what should I say, what's the contribution for which Hennessy and Patterson were given Turing Award?
No, for risk,
Huh?
for the way they invented
Okay,
the
RISC
micro.
processor. All right.
Yeah,
So,
the risk.
what is this RISC processor? Any idea? Or how was it
Ma'am,
different from the previously designed processors?
Now, up till even now, Intel and other competitors and other vendors have been using complex instruction sets where they've had many different instructions or they've had very specialized instructions. So, I think Hennessy noted in his Turing lecture that there was one very specific uh, operation code for polynomial evaluation, but then it was almost very rarely used. Its inclusion was also its inclusion was not feasible, and the memory that was taken up by these complex instruction sets was getting higher. So what they decided to do was strip down the non or the barely used components and then have the most used components as the base instruction set, and have the
Okay.
operate and have the processor run on these. So they said they achieved up to, if I remember correctly, 3 to 5x performance improvements.
Mm. Okay. Anyone else wants to say anything else? In fact, when I worked in an RSA, that is when the RISC processors came into picture. So much noise was made about the RISC processors at that time. The Sun microsystem processors and all were, changed into RISC processors at that time. In fact, I was thinking I should try and see if I can contact my friend. I've been out of touch with her for a while, but she is one of the people who was involved in the Ultra Spark chip development in Sun, I think. And later, her boss was one of the Juniper founders, so she was asked by him to come to Juniper. So she's also involved in the first hardware router implementation. Let's see if I can get her to talk in this class at some point. So, um, the sort of questions that Hennessy and Patterson asked themselves in some sense to create the RISC processor are the questions we'll be actually visiting today, which form the principles behind how do you design an instruction set architecture. Okay. So if we go back to the old architectures in, which no longer exist, that's why I wrote here, but the stack and accumulator architectures obsolete. You might have read about them in your COA.
Yes,
Am
ma'am.
I right?
Yes, ma'am.
Accumulator architecture, especially, I remember studying. So anyway, it's all, these are no longer existing architectures, right? Nobody is using an accumulator architecture where one of the operands is always the accumulator. Neither are they using stack architectures where they had a special stack structure in the processor. So the operands are always at the top of the stack. So if you want to operate on the operands, you have to pop the stack and, basically push back the result onto the stack sort of an architecture. Neither of these are no longer, used anymore, so we need not worry about it. Now, there are other one is basically the register architecture, what is called the load store architecture. So you have a set of general purpose registers and you load data from memory into the registers and do the operations in the registers and store back into the memory. If you have purely only registers on which you can do the operations, then it is called as a register architecture, right? So MIPS, PowerPC, ARM, which are still in existence, are examples of register architecture. Sadly, right, Sun Microsystems, SGI, all these companies which were very, very famous for their processor architectures, very, very famous for their hardware engineers, have actually gone belly up. They are no longer existing as companies, and certainly their hardware sections are no longer existing to my knowledge. Oracle bought Sun, but not for the hardware, as far as I know. So register memory operations, that is, one operand is in memory and one is in register, and you can operate directly from register, from the memory itself. This architecture is possible in Intel x86, right? It is possible. Intel kept using it, and I have to say that there are a bunch of people who are familiar with hardware, very very fond of electronics, who hate Intel, right? They feel that the Intel architecture is really very very shabby. And I remember my brother-in-law was one of them, and who allowed to have a computer which was Intel and Microsoft free. So he bought a motherboard with a processor which is non-Intel, built his own computer and installed Linux on it. So there are people like that. Unfortunately, however, Intel has become such a horrible monopoly that I tried buying various systems in our lab. So we actually bought one Sun system at one point with 20 terminals. I feel very bad that that was put aside, but to my horror, I later discovered that that particular processor also is an Intel clone. So it's not a standard Sun processor that it had. So Intel at some point became very, very famous, became a monopoly. But interestingly, that Intel, also actually does something very weird. We'll talk about that. But so we have currently processors which are register architectures or register memory architectures, right? Now, I think the next question is, how do we access memory addresses? How do you define memory addresses, right? How do you give a memory address in an instruction? How do you access memory addresses? How do you interpret memory addresses? So there are three things. One is, the byte order, which you know.